everyone. My name is Gideon from Mkwawa University College of Education, and today we are going to demonstrate the real-life application of ordinary differential equation. Actually, ordinary differential equation is the equation that contains a known function with its derivative. For example, dy dx is equal to 3x squared. Now dy dx, it can be the rate change of the body. Now through this equation, we are going to demonstrate three applications of this ordinary differential equation. Number one, we are going to demonstrate the Newton law of cooling of a tea, and the second, separation of the mixture, and the third application is can be applied in brain solution. Now I'm going to welcome my friends so that they can proceed with the next.
My name is Joseph Michael Paul. I'm going to demonstrate the brain solution as application of ordinary differential equation.
My name is Mtipa Ashir Rashidi. I'm here so as to demonstrate the application of ordinary differential equation in separation of mixture.
Okay, in this video, we see how a tea bag releases its flavor into the water over time. The process follows a separable differential equation because the rate at which the tea diffuses depends on how much tea is still inside the bag. In short, the mechanism is that concentration change over time, and that change can be described by separating the variables in differential equations.
Brain solution as an application of differential equations. A brain solution is a mixture of salt and water. In differential equations, brain problems are used to model how the amount of salt in a tank changes with time when solution flow into and out of the tank. Basic idea: consider a tank containing salt water. These are two processes occurring. Salt enters the tank through the inflow. Salt leaves the tank through the outflow. The rate change of salt in the tank is given by dq over dt equals to R in times C in minus R out times Q over V, where R in the inflow rate, the in concentration of incoming salt, R out equals to outflow rate, V the volume of solution in the tank, Q over V concentration inside the tank.
Okay, the application of ordinary differential equation is that it's applied in the Newton law for cooling of a tea. Now, if a hot tea is left on the table, it's tends to lose its amount of heat to the surrounding. And as the temperature increases, the temperature of the tea tends to decrease to the surrounding. Now, if the temperature of the tea is 90 degrees Celsius, at the time of 0 seconds, and the room temperature is 25 degrees Celsius. Now here, the temperature of the tea is less to the surrounding. And if the time increases from 0 seconds to 15 seconds, you will find that the amount of temperature of the tea tends to decrease from 90 degrees Celsius to 65 degrees Celsius. Here, the tea tends to lose its amount of heat to the surrounding. Now, if the time increases from 15 seconds to 30 seconds, you will find that the temperature of the tea tends to decrease from 45 degrees Celsius to 30 degrees Celsius. But the room temperature remains constant as 25 degrees Celsius. Now, the general distribution is that the rate change of the temperature is direct proportion to the temperature difference. And if we remove proportionality side, we find that the rate change of the temperature is equal to the negative K times the temperature difference. Now K represents the rate constant, T represents the T temperature, and the TA or TS represents the room temperature or the surrounding temperature.